Hi, I'm Dr. Harris here. In this video, I will present to you Chapter 14 of the textbook. Chapter 14 deals with two very important concepts in statistics: correlation and regression. And both of these techniques, we will talk about simple regression. Both of these techniques relate two variables to each other's. And you know that a variable is a measurable characteristic of a population or sample. So two variables can be related to each other using these techniques. These two variables have a relationship. One of them is an independent variable. This is the predictor or the actor that's acting on the other variable, which is called the dependent variable. So the independent variable goes on the horizontal axis and the dependent variable goes on the vertical axis. So I'll give you an example. For example, if you have some data about the houses in a real estate market, and two of the variables that amongst many variables in that data set that you see are the price of those homes and the size of those homes in square footage. Definitely these two variables are related to each other's. The price is related to the size and the size is related to the price. So which variable is independent variable affecting the other one? Well, the independent variable in this case is the size of the home, because the size of a home has an effect on the price of the home. So the independent variable that is acting on the other variable is the size of the home, and the dependent variable would be the price of the home. So the variations in the size can explain the variations in the price. So the correlation analysis measures the strength of relationship between the two variables. So in our example, the size of the home, which would go along the x-axis in this graph, and the price of the home, which is going to go along the y-axis. The relationship is linear. So the two graphs that you see on this slide, the one on the left hand side is showing a positive relationship. So when the x goes up, the y goes up. Each green dot in this graph shows a relationship as to where the y is when x is a certain place. The graph on the right hand side shows a negative correlation, means that when x goes up, the y goes down. So this can be price and quantity demanded. So if you're selling pizza in a shop, if your price is $10 for a medium pizza and you would sell 10,000 pizzas a month, if you raise the price to $15 per medium pizza, then your quantity demanded is going to go down. So when one goes up, the other one goes down. So in this case, the price would be the x-axis, the independent variable, and the quantity demanded would be on the y-axis as a dependent variable. So let's take a look at this example. A new car dealership wants to examine the relationship between the number of TV ads that they run per week and the number of cars sold. So the assumption is that the more ads you run, the more cars you sell. So which one of these become independent variable? The ads, because the ads are the predictor of the cars being sold. So the x-axis, the independent variable, would be the number of ads you run. and the y-axis would show the number of cars sold. And if you collect the data, then you can do correlation analysis to see if the graph is upward sloping. Positive slope means the more ads you run, the more cars you sell. So let's say we collect some data over a 6-week period. Week 1, 3 ads were run, 13 cars were sold. Next week, 6 ads were run, 31 cars were sold, and so on and so forth. The graph on the right hand side shows a scatter plot that shows the relationship of number of ads to the number of cars, and each dot shows one relationship. Now if you were to draw a trend line, you would see that trend line would be upward sloping, and it's called a best fit line, which means that it's going to go through these dots in a way that the average distance from each dot to the line is minimal. So for example, the lowest dot in this is above 3 at 3 and 14, and it shows that if 3 ads were run, 14 cars were sold, and then if 4 ads were run, 20 cars were sold, and so on and so forth. So that is a scatter plot. Shows the relationship of an x-axis variable with the y variable. Now the correlation analysis can be performed. We have done all the correlation analysis for the purposes of this course using Excel. That's how the correlation analysis is done in real life these days. Nobody calculates it. But if you were to calculate it, the method is shown in this slide and the next. So the correlation coefficient is calculated either through those calculations or using a statistical package such as SPSS or Megastat, which is an application that gets installed on Microsoft Excel. You get a correlation coefficient R, and that shows how strong or how weak the relationship is between the two variables. The correlation coefficient R ranges between -1, showing a strong negative correlation, means that when one goes up, the other one goes down. In our example of pizza, when you raise the price from 10 to 15, the quantity demanded is going to go down. And the positive one shows a perfect positive correlation. That means that we studied the example of TV ads. The more ads you run, the more cars you sell. And if each additional ad is going to give you one more car sold, then there's a perfect positive correlation. The correlation can be in between these two as well. So for example, a correlation of -0.37 would be a moderate negative correlation. The textbook gives you a comprehensive picture of how to interpret a correlation coefficient result. You would need that when you do the data project and you're trying to describe what did you find out in your own data. When you get an exact 0 as a correlation, that means there is no relationship between the two variables, and any relationship that exists is just a mere chance. The different correlations that you see here, the graph A shows a perfect positive correlation. The dots are lined up in a way that the relationship is 1 for 1. When x goes up by 1, the y goes up by 1. The graph B shows a perfect negative correlation. When x goes down by 1, y goes up by 1. Perfect negative correlation. A C shows an R correlation coefficient of 0.6 that shows a moderate positive correlation. And the graph D shows a moderate negative correlation, and then the last graph graph E shows a zero correlation. So that's how the scatter plot looks like with all of these R values, correlation coefficient values. This is how you would calculate a correlation coefficient. In the 21st century, we don't do it anymore this way. We have statistical packages that we use to run correlation analysis that gives us the same result. For the purposes of this course, I have provided you with Megastat, which is a statistical application that gets installed inside of Microsoft Excel, and you can run correlation analysis through that and find out what the correlation coefficient R is. So if you wanted to just use Microsoft Excel, you can use this formula to calculate correlation. You go into an empty cell and define the series of x-axis first. In this case, the adds are the x-axis or the independent variable. So the formula is showing that all the values from A2, where the data starts, to A7, and then comma separated the two variables, to the y-axis, which is B2 through B7 inside the parentheses, and every formula starts with an equal sign. So if you type in this exact formula and describe all the values, you can also get correlation using Microsoft Excel without Megastat. The regression analysis shows an equation, and this equation tells you what percentage of y is explained by the x. If you had a certain x, you can solve for y. That is a simple regression. A simple regression only uses two variables, an x variable, an independent variable, and a y variable, a dependent variable. Multiple regression, on the other hand, shows a relationship of multiple different independent variables on one dependent variable. So number of cars sold, one of the things is the ads. The second thing could be the skill level of the sales staff measured by some technique. The higher the skill level, the higher the number of cars sold. The third could be the number of hours that the dealership is open in a given week. So you don't just rely on one independent variable predictor, but many of them, and then the multiple regression shows you how much each one of them is responsible for a change in y. So this is the regression equation. Y equals a plus bx. A is a constant value, b is the slope of the line, and x is the independent variable. So if you have a value of x, you can find out a given value of y using a simple regression. That concludes this chapter, simple correlation and simple regression. Please watch my videos related to how to calculate correlation and regression, how to design a regression equation, and calculate correlation coefficient R using Megastat and Microsoft Excel.